Hey, what's up? It's Jake, and I'm here today to talk to you about functions. So you've been seeing me use functions, so you're probably familiar with it. But now we're gonna break into like what exactly is a function and how does it work? Why do you need to use them? When should you use them? And how they're constructed. So start out with a simple definition, which is a function. A function is a sequence of instructions that perform a task that are bundled together as a single unit. Okay. So let's look at a function. So here is an example function. So function begins by saying we need a def keyword to define this function, and then you can name it whatever you want, function name, and then it's followed by an open and close parenthesis and a colon. Once you do that, you just indent and you can do whatever you want. So I could say print hello world, for example. And then if you need to use that function, you just call it function name. And then your code will go, okay, skip this line. Okay, you defined a function. This is what's in it. Oh, run the function, and then it will run it. So that's the basic innards of creating a function. Very simple. And this little, these two lines right here, this is one unit of code. It's important that you learn the word unit because that will come into play later. So this is just a sequence of instructions where I could say, let's say I have a message, right? I have a message and it's going to say, some kind of string. We'll just say it's like hello, for example. We'll use message 1, message 2, and this is going to be world, like this. And then instead of doing this, I can just say print message 1 plus message 2. And we should get, with no spaces, hello world. Yep. I'll just add a space here. And that would be a function. Now, the reason I did this way is so I could show you and illustrate that when you call a function, it's a sequence of instructions. So this is step 1, this is step 2, this is step 3. So this is we've been talking about sequences in the forms of lists and strings and other objects. Well, a function is also an object, and each step in that object, because we said that objects can have a method, right? So the function name has a method, and these are the 3 steps that it takes. So, yeah, so a function may or may not return an output. It might just save this. It could just say like message total equals, and then I'll just add these two, and it runs, but like it doesn't do anything. This variable is never used. In fact, in some cases, you could even say, go ahead and just return message total, and it would look like it does nothing. Like if I just ran this, it just doesn't do anything. What you don't see is that it creates a thing called hello world. It just doesn't print it out. It doesn't do anything. So in some cases, you can see what it does. In some cases, you don't see what it does. If the function doesn't have a return statement in its body or no value is given to the return statement, technically the function returns none. And there's a design choice reason for this, and we won't get into that, but just know that if it doesn't do anything, it actually does return something. It returns none. And returning none is different than returning nothing. So why would you use a function? So it's probably one of the most important concepts for any programming language, but it reduces code duplication. It helps split complex tasks or procedures into smaller blocks or units. And then you can hide some of the implementation details from users, improve traceability, and improve readability. So let's talk about reducing code duplication. So imagine you're doing this like scientific piece of software, right? You need to calculate like prime numbers up to a certain limit. And we did this, and I made a Python script for this prime generator. So imagine that I don't want the user to have to see all this garbage. So if I did this, then they could just import good primes. They could have their own script that just says import good primes, primes, and then they would just run without this thing, and then you would just run good underscore primes and then pass some number to it. And this would be literally their entire script would just be this, and they wouldn't have any of this stuff. So if you had a very complicated scientific piece of software that was quite long, you could basically can get rid of that so people can't see it. And then if I just call this every time I need a prime, then I don't have to type this every single time. I just go, okay, and then take a prime number, take all the prime numbers between this, and then do something. Okay, and then we're going to do something else. And then later on in the code, I go, okay, now go grab the prime numbers for a different range, and I can just pass that, and I don't have to type this code again. I can just reuse this function instead. So yeah, it's kind of error prone to cut and paste everything and whatnot. It can be very, very dangerous because you could break something in one place, but it's not broken in another, and then it's hard to find, and et cetera, et cetera. So yeah, so that's one reason. Your code will be shorter. It won't suffer from inconsistencies between old ways and new ways of doing something. And you won't have any undetected bugs left behind due to some weird copy and paste failure or an oversight of a person or a human error or whatever. So use functions. There's really no downside to using them. So the other part was splitting up complex tasks. So they're also useful for this. And the end result is that your code benefits in several ways. Readability, testability, and reusability. So a simple example, so imagine you're doing a report at work, right? And your code needs to fetch data from some data source, parse it, filter it, polish it, and then a whole series of algorithms need to be run against it in order to produce results that would feed a report class, right? So it's pretty common to see like one big, like do a report kind of function thing. And there are like tens, hundreds, maybe even thousands lines of codes that return some kind of report at the very end of it. Well, instead of having one giant script to do this, you could write, so for example, instead of having like hundreds and hundreds of lines of code, I could just make a function called do underscore report that takes some kind of data source that we get from somewhere. And inside of this function, I could just be like the data equals and then fetch data from whatever the data source is, data underscore source. All right, and fetch data would be a function that's defined somewhere. Maybe it's even in here in one of my files. And if fetch data is messed up, I just go, oh, I need to fix fetch data, and I fix fetch data, and then I go back over here and I fix it. So you could have a data definition, you can have a parsed data function, you can have a filtered data function, a polished data function, and then all this do report does is it gets the data, it parses the data, it filters the data, and then it would polish the data, and then you'd end up with some kind of final data, right? And then you'd have a report that actually builds the report, and then after that you would return the report and maybe email it or do whatever you want to do. So essentially you can make a function that just uses other functions, and that makes your code more reusable because you've built in a way to have hundreds and hundreds of lines of code or even thousands of lines of code into one function that just calls 6 other functions, and then each of those functions maybe is 10 to 50 lines long, and it's much easier to fix a 10 to 50 line piece of code than it is to fix a 2,000 line piece of code. So yeah, you can also reuse it in other places. So if I had this 2,000 line of code script in here, and I was doing something in the middle of it that I could use in a different report, well, I can't reuse that one piece of that code if it's just in one big giant bundle of code. But if I had it broken up into smaller pieces, I could call that function for maybe 6 different kinds of reports that all need to fetch data. Maybe they do different things with it, but they all need to fetch data. So fetch data might be a function that I reuse in every single report script that I run. So that's why you'd want to use it for splitting up a complex task. Hiding the implementation details I kind of covered already, but like in the same like example, you could go through code to do the report and get a pretty good understanding without reading a single line of implementation to go, what does this do? And I'm like, oh, okay, it fetches the data and then it parses the data and then it filters the data, polishes the data, and then runs the report itself and then returns a report. And you would know that that's what it does without actually reading any of that code. So then there's improving readability, which programmers sometimes don't see the point in writing a function with a body of like 1 to 2 lines of code. But you should do that because if you're using like matrices or something like that, it can get pretty complicated really quick. And so I won't like go into specific examples and make this take longer, but just know that improving the readability does make it nice because instead of having just a bunch of code that just does a bunch of stuff, if you define it and you name it, then you can name it. And if you have a good naming convention, then be like, oh, I know what this does. It returns prime numbers or something like that. Or you can look at this and be like, why is there two things? And be like, oh, this is a bad way and this is a good way. Like you could know that just by looking at my code and not know what in the heck this is. So there is some readability there, especially with function naming conventions. And then the last part is improving traceability. So imagine you coded like a e-commerce website. You display the product prices all over the page, and the prices in the database are stored differently, but you want to display them on the website with like a 20% off price. So if you were to just show the price that's in the database, it would be wrong because the prices stored in the database don't take count to some kind of sale or something like that. So if you're doing web programming in JavaScript or Python, either way, you could calculate different kinds of prices um, in your code, and that's fine. But if you start selling products in different countries and all this other different stuff, like there might be different tax rates and sales rates and all this other stuff. And if you want to know where you're performing all these calculations, it's very easy to do it in your code to look at a function and say, oh, this function is for calculating it in this country, this one's for calculating it in this other country, and be able to just adjust those as needed. Um, which is pretty cool because then you can take that one calculation, and if you have multiple places on your website that are calculating a sale price, you could just take that one very simple, like, take this number and multiply it by 0.8 to show a 20% off. Even though that's only 2 lines of code, the fact that you created a function means that every single place on the website where you have a different page, like a different file, which if you've never made a website, especially e-commerce, can be very, very lengthy. You can just reuse this function over and over and over and over and over. And every time that you use it, you save 2 lines of code. So if you use functions everywhere, imagine how many lines of code you would save by just using functions instead of copying and pasting stuff from one page to another page. So yeah, you could write something and import the function and use it anywhere. So traceability is nice because if you're trying to figure out where to change something in order to make it take effect everywhere, functions allow you to use one place where you can change one thing and then everywhere it gets updated. So that's kind of goes into also the reusability of it. So that's just an overview on functions. If you have any questions, let me know. We've been using them a lot, so I didn't go into too much detail of typing one and giving you examples because I tried to do it just so you kind of learned it on accident. Yeah, and then that's it. So next video, I'll go over scoping and naming resolution, and then I'll see you there.